I've got two great speakers here today that I'm going to pass this over to. Doug Tomaslov, thank you for your time. Thank you for being here. And let's get right into it.
Oh, great. Thanks, Joanna. Um, you know, we're in really interesting times, and the phase that we're in has resulted in a great deal of chatter about the degrees of, um, intensity that AI has brought, the wide variety of potential risks that it creates, and it was very interesting for me yesterday to be on a panel in Boston. Admittedly, it was in Boston, but you know, it did reflect a really interesting set of circumstances where um, people who are CISOs, people who are in the SOC, and participants in this cybersecurity event were both playing down as well as expressing real concerns about a whole set of risks connected to software and modeling. And there may be this raging debate about whether these attack surfaces are truly new. But what's undeniable is the acceleration, faster execution, far greater malware volume, more diverse and adaptive payloads, richer contextual scams with human-like fluency. I mean, everybody can see that using generative AI results in just better grammar. And an ever-expanding perimeter that's increasingly difficult to defend. And so Tomasoff and I have put together this presentation for you to kind of come to grips with this software risk as a result of the advent or the recent advent or the new AI that has brought about changes in our operating environment. So, Joanna, we may want to go to the next slide. So I have a background in cybersecurity. I'm the founder and first CEO of Black Duck Software. I'm also the advisor and board member to companies that have become really important to the cybersecurity and blockchain and AI industries. One of which I'm on the board of is ReversingLabs. So in addition to that, I serve as a fellow at the Harvard Business School, where I just completed a semester of teaching ideation and prototyping uh, at the business school, where we had 77 students who were, I noticed one or two in the webinar, attending this webinar, and basically that was a very successful class at HBS, and we're going to continue it next year. Thumbs up.
Thanks, Doug. And my name is Thomas Lopericin. I'm the Chief Software Architect and one of the founders of Reversing Labs. Happy to be here on the webinar with Doug. We're going to talk about one of my favorite topics, which is threats, and subsequently to that, also how ML and AI are making those threats even more relevant today. So take it away, Doug.
Thanks, Joanne. So this handsome guy is wearing a pair of glasses that you may be familiar with or may not be familiar with. These are Ray-Ban glasses that are offered by Meta, which which are filled with AIs. There are 12 AIs in there, including computer vision and a variety of other types of AIs that allow you to call up data and access all kinds of uh, some things that you can see while you're wearing the glasses. The reason why this is really interesting, and I'm subjecting you to a picture of me with handsome glasses on. The reason why this is really important is this is a new attack surface. That is to say, as a result of being able to call any number of generative AIs, although there's a standardized AI from I believe it's Gemini in the Meta glasses. Um, you can also call DeepSeek. You can also make API calls, and a variety of things that subject an operating environment to risk if I bring myself and my glasses into a enterprise and I may not be even working there. I can bring along some bad acting or risky software situations and potentially modeling situations or data poisoning situations. So these are some of the things that we will deal with. Why don't we go on to the next slide during the course of our presentation. So AI in the supply chain is a really important subject insofar as the SDLC, the software development processes, have been now augmented by the ML or AI development processes, and we'll talk about those. And we talk about why AI breaks the traditional cybersecurity um, protections and technologies that help defend corporations and individuals from risk. And then we'll talk about threats, risks, and which are native to the AI supply chain specifically, dealing with model poisoning, data poisoning, issues related to agents, which is one of the more intensely debated as well as concern areas of concern. And then we'll talk about bill of materials or bombs, the AI bomb being a very important one of them. But we at Reversing Labs use an S bomb or a software build of materials, which is important for software development tracking. And finally, we'll talk about how RL or Reversing Labs will help. Tomislav, what do you think?
That's an excellent agenda. Can't wait to start. Go ahead, Doug.
It's excellent because we worked on it together.
All right.
So what is the impact of on cybersecurity in this day today? This is the end of 2025, and what we can say is that traditional attacks have become hyper dynamic. That is to say, there are models which we've encountered companies that have models which have been attacked, and that there are open source components that expose companies to attacks. So there's also excuse me, the traditional vectors which cause potential attacks. But the new attack vectors include dependencies and APIs and package containers and these new artifacts in models, as well as and in data, are things which are concerns which require new countermeasures in the security area. The interesting thing that is very consistent across events and discussions is that the turning point has really been November of 2023, when OpenAI introduced ChatGPT. I think it was 3.5 at the time, and we're now at 5.1. During the course of time, with all those upgrades, while there has been security, which has been introduced along with those new versions of ChatGPT, what's happened is that the bad actors have learned how to adopt to these generative AIs, as well as the AI models in general, and the new countermeasures which are being introduced into corporations. So we're definitely in a time of change where the good actors are putting together defenses, and the bad actors are putting together countermeasures. And so the supply chain is the critical demarcation point where it's important to know that on the AI side, AI is no longer peripheral. It's um, it's a part of the SDLC and the MDLC. You may call the model development life cycle. And so while AI writes the code and AI embeds in products, what we have now is AI which is launching attacks. And so, what's new on the horizon, and what we'll dive into in just a couple of slides, are these model embedded malware or MEM, which is in many respects uh, newly confrontational in this age of more AI, more models, and more data that is being accessed or under threat. Um, so poison training data is something which has been around for a while, but in the last 3 years, since the introduction of it's actually only been 2.5 years, but um, in the short time since the introduction of OpenAI, many executives, boards, and of course security professionals have gotten very, very focused on this area of poison data because data is so critical to the efficient and productive functioning of AI. And so I believe, unlike many of the people who are chattering these days, I believe that there are new attack surfaces. And the new attack surfaces, especially in the AI software supply chain, um, are are compounded by models and agents talking to software. So that raises the whole issue of why AI breaks traditional cybersecurity. AI capabilities can identify vulnerabilities, can run large scale socialization campaigns, and they can generate exploitive code. So this is fundamentally from the code-based protections and the code-based detections that have been in place for years now, um, since the early 2000s when we've had static and dynamic analysis and analysis of signatures in particular. And then there are human scale attacks which characterized software, malware, and attacks in the past. And of course, OS level artifacts were one of the important or one of the primary ways that bad actors, um, initiated their attacks. And then finally, the supply chain, especially the SDLC, was had different points of penetration. And and what we have today are malware embedded in models. So this MEM situation is arising more and more frequently. And what we can see is that malware isn't always code, it's actually math too. That the payload is not expressed in atoms, it's actually distributed with a combination of math and code. And then the activation can be semantic in a context, as opposed to like software triggered malware. And then finally, what we have is the uh, the triggers themselves can be tokens. LLMs are run with tokens and literally billions of tokens. And activation can be below the surface in graphs. And weights and measures, standard part of LLMs, can cause the perturbations. Um, and so what AI has done is in many respects created new ways to hide under diffuse. This is expressed extremely well. Under diffuse patterns across layers, sparse neurons holding triggers, and then you know prompts introduce the whole vector of ghost-like features that can be included into generative AI as well as other chat situations and generate all kinds of badly behaving models or poison models or any number of other malwares. Tomislav, did I cover everything?
Well, I was going to add, really, which is there are examples of these attacks ongoing right now. There was a pretty recent research from CrowdStrike which talked about latent behaviors in DeepSeek model, which exactly as Doug was explaining, through specific types of prompting, the model would generate unsafe code, which can introduce vulnerabilities and even intentionally introduce behaviors to make the application not execute as it should. And that's specifically problematic if you are basically outsourcing your thinking to a machine learning model or an LLM that's going to generate all of your code. And then you're in a situation where code might work, but you don't understand what the code does. And that code itself could be vulnerable, it could be malicious, it could have, logic bombs embedded and stuff like that. And the only trigger for threat research is knowing exactly how to prompt the model so it generates the output which is such that it puts your application under risk.
Exactly. And in addition, um, it's important to raise, at least at this point, especially in the on the mem slide, that we're what we're seeing is massive reuse and blind trust in third-party models. So many companies and individuals are downloading models from Hugging Face, for example, and other sites. And there are weak or relatively absent controls which are applied to these kind of situations. And so um, what we have is, I believe, an expanded threat surface because there are now these, you know, places where people can get models which are not well, which are not fully vetted, let's say. Let's go to the next slide. And this reinforces the entirety of the modeling situation. There are threats and risks which are native to AI models, data, and agents that enterprises simply have to get attenuated to. And this may require guardrails around, for example, downloading models and other behaviors. But if we can go to the next one, AI's new vulnerabilities are really related to these new attack surfaces like model weights, data sets, the training pipeline, inference, APIs, and uh, orchestrating, well, detecting and classifying these different situations are really important. And basically putting in place ways of detecting these kind of potential vulnerabilities in models today is one of the more critical action items that SOCs and security professionals have to do. So one of the more interesting things, and a thing that I've been spending a lot of time on recently, is the whole issue of data. What I find is that while simultaneously um, enterprises are extremely, or organizations in general, I should say, are extremely interested in accessing more data, using more data efficiently, using infrastructure in particular to delivering data to AI model developers, as well as just generative AIs and other AI applications. It's very important to know that as the picture depicts, there could be a foul mussel or a foul clam in the mix where there are situations where poisoning has come in through training, um, that tampering has occurred during distribution, and then malicious behavior has been brought about during inference or during the use of prompts in chats and in generative AIs, where there are hidden triggers and parameters that are manipulated. Um, these are these present new challenges to companies, and putting guardrails around the use of well, this raises the whole issue of shadow AI. Putting guardrails around the use of generative AIs that are not approved by a company is one of the things that companies are considering much more actively today than over the last 2.5 years, let's say, because with DeepSeek and Mistral and other generative AIs that, as well as secondary LLMs that are out there, that companies just simply have to protect themselves. And while you don't want to stifle innovation and you don't want to stifle the adoption of AI use in companies and organizations, the reality of these models and data that are potentially poisoned is something that just demands that companies be more vigilant about shadow AI and putting guardrails in place. So, one of the things that many companies are concerned about is MCP, which is Model Context Protocol, which is a which can lead to reasoning leaks, data, an accidental mixing of public data with private or uh, proprietary data. And then the whole issue of what's called trusted execution, wherein models are fully trusted and execution of models are not executed by outside parties, but instead are trusted by people who have built them or who are proper users of it. And then tool exposure is another thing, especially when it comes to open source, use of open source tools. Behaviors are now being, you know, more so evaluated. So it's critical that security um, is now evolves to include behavioral parameters, and that latent capabilities are detected. And so it's very important that companies understand that the new platforms have to contain more and more capabilities to not only identify the classic software related issues and the new math related model issues, but also behavioral issues which are contextual. Um,
Just to
what
add to that,
happens?
Doug, as
Sorry.
an example of one such attack and how sneaky these things can be. So in the last couple of weeks, companies in the AppSec space have started to discover malicious MCP servers. Another company called Koi has discovered one of the first ones, and that particular MCP server was malicious in a sense of handling your email data. but it didn't only do what it's supposed to do, it also forwarded all of the email messages that it received as kind of like BCC copy to an attacker. So BCCing an email isn't malicious by itself. So traditional, malware detection capabilities would just say, "Yep, you're just sending an email," but the email is of the attacker. So that means that MCP servers introduce additional risks into the organization and behaviors that need to be looked at differently because the threat model isn't really, oh, it's going to install something malicious and it's going to launch an application. In this case, it's about data flow. It's going to reroute all of your or copy all of your email messages to an attacker. So that's an interesting point to kind of raise about MCP servers and governing them as well.
Yeah, and interestingly, I was talking to a law firm yesterday who was very concerned about note takers, note-taking applications, and attackers rerouting notes from confidential legal notes, which law firms just assume are behind a firewall and then are therefore protected. And the same thing goes for other note-taking applications on whether from Zoom all the way through like handheld ones on mobile machines. So this the models can be the inroad for this kind of behavior, and so it's important to just keep that in mind as models proliferate. We can go on to the next slide. And here comes in, one of the new attack surfaces, which no doubt is going to play a bigger and bigger role in our security efforts. Agents and AI agency is becoming a significant threat, and the attack types are access related and escalation related. You get supply chain vulnerabilities, which are agents that are talking to other agents that access either software or models and expose vulnerabilities. Um, Stimulating hallucinations, which I was worried about in parties that I went to, but in the past, but now are concerned about models and its stimulation of hallucinations. Um, Many people are now getting much more aware of the issues of prompts that show up in generative AI and their exposure to potential threats, manipulation, changes in logic, all kinds of code which are built into the prompts, which change the nature of the attack surface, but also specifically introduces access to data and all kinds of privileged information behind the firewall. So, and then data poisoning is something which is coming up much more frequently um, with models and with the need to introduce more and more data. The ravenous kind of demand for data is also simultaneously increasing the probability of more and more of these attacks. Um, and we're going to start seeing much more um, how do you put it, like things in the press which are reflecting these data poisoning and model hijacks, which are becoming which are moving from being theoretical to being actually implemented. These are counterbalanced by guardrails, um, you know, new approval processes, safeguards, and overrides. Overrides, in particular, are important on with AI agency and AI threats. Um, And then the whole issue of identity, which we haven't really dealt with thus far, but this raises the whole issue of hijacking and many other types of attacks. But what we're going to see a lot of in the coming months and years is this um, is protecting against identity threat theft and identity related um, uh, attacks which are caused by agents. So with that, let's go to dig more into this. And just really almost as a refresher that the modern AI stack includes LLMs and we don't mention it, but SLMs, which are small language models, which are sometimes vertical and data rich, and ML models in general, which are a big part of the AI supply chain. The LLMs, excuse me, in particular, create this vast number of users who are using AI in a horizontal manner, but and using foundation models in that. But then we have, in addition to that, tools and other and open source models, for example, which extend the attack surface, but instead of a vast horizontal market of this is either a diagonal or a vertical market of specialized users who who can increase, the number of well, just simply increase the attack surface. And then agents in and of itself, because they are autonomous, can can cause harm. It's simple as that. But also add complexity to specifically the security models that companies are have been attendant to in the past and need to now expand and improve to take into account not only agents but also the various things that agents can trigger in the uh, in the enterprise. So these things are the foundation stones of the modern AI stack. And if we can go to the next slide, um, what's important to note about this is that there are countermeasures. One of the countermeasures which have to come into more play is this bill of materials for the AI supply chain, or AI bomb. And some people call it an ML bomb when it's applied to ML. But this is where the list of components from model weights through RLHF policy layers through agent policies can be uh, uh, set down and analyzed and also documented. And so the reason why this documentation is important is because you can do comparisons and communicate to various parts of the organization what are in place and what needs to be fulfilled. Um, this is this is part of the overall. This is going to be a necessary part of the overall process of not just fine tuning, but also um, putting in place security measures which counteract the bad actors' use of AI across the board. Tomislav, do you want to add anything to this?
Yeah, I mean, there's many different aspects of models themselves. And if you're building a comprehensive inventory of all of your software, you have to take into the account not only the software that you use, to load the model and to do inference, but you also need to take into considerations the models themselves and also any additional third-party cloud services that the model is going to be interacting with. So that becomes the reason why some people are referring to an AI bomb as this comprehensive a bill of material for an entire service. And it literally involves, the software, the models, the training data, some also contain hardware information, even the carbon footprint, which was emitted during model training is part of that bill of materials, for example. Verification data sets and also cloud services. So it's very comprehensive. And you can also, think of it as like a machine bill of materials as well, because AI is obviously going to be running on some hardware as well.
Very good. So let's go on to behavioral analysis. This is going to become increasingly frequently referenced. And the reason why is because AI workloads require runtime behavioral analysis in order to, identify, well, monitor, but also identify bad acting situations, um, especially when it comes to agents. AI agency is introducing a new level of cybersecurity attacks, and the counterbalance to that is behavioral analysis in conjunction with AI bombs and other guardrails, which help not just detect and identify all these bad acting software, but then ameliorate and then monitor the whole range of measures that have been taken into place. Anything to add, Thomasoff?
Yeah, I mean, agents are a new boundary, if you will, for security, because you almost have to think about it as a person, because it is doing actions on behalf of the person. Its motivations and instructions can obviously be altered as the agents are doing their thing. And some of the guardrails that you put in place might also not be, well, shall we say, they can be creatively bypassed by the model itself. There have been many examples of models inventing creative bypasses of the behaviors that were strictly restricted to them as well. So it's an interesting point in time for security, because all of these challenges are kind of adding up when it comes to securing the environment.
Very good. Okay, on the next slide, you realize that there is a taxonomy that can be not only articulated and analyzed, but also expanded and um, utilized in such a way so as to cover all the different possibilities of attacks and just bad acting software and model threats. So the reason why we put this particular slide together was for summary purposes, but also to give you an idea of the dimensions of this new attack surface. There's data level attacks, which we've referenced in this presentation, model level attacks, inference time attacks, for example, in prompt injection, which is very prominent, but there's equally jailbreaking and triggers which activate within models. And then there's the agentic attacks, which are going to be increasingly prevalent, and the uh, always present software supply and model supply chain attacks, which are which have been documented recently. Um, I strongly recommend that that people out there and that are running um, security groups, SOCs, and with security professionals create their own equivalent of this slide and one, identify instances of these as they emerge, as well as just do training against these things. Model weight manipulation, for example, is a very subtle model level attack. And, you know, seeing the behaviors behind changes in the models and hallucinations, instances of hallucinations which occur, as well as uh, other kind of behaviors, is something that people have to be trained on or at least made aware of, and then subsequently um, uh, modeling or watching in their models. And the same thing goes with these other attacks. They can be very subtle, but they can also be, major devastating. I mean, they're the range has increased. So, from DDoS attacks many years ago to, you know, poisoning of models and individual data points being manipulated. It's I believe it's a new world. And so all this recent chatter about, the attack surfaces not being that new, I think is is being too conservative. I think there's many of these new attacks are new, and their dimensions are from this very subtle to the potentially devastating, and people have to be better educated about them. We can go to the next slide. So we'd like to take a poll at this point and allow you to, vote, let's say, on which of these AI native threats are the most concerning to you and you feel most unprepared for. So this is an opportunity for you in the audience to give us input, as well as input that can be shared during this webinar. So we recommend, we'd love it that we get robust participation from you.
Absolutely. Thank you, Doug. Which brings us to how Reversing Labs can help, especially our product called Spectra Assure, meant for software assurance and models being part of that scope are something that we can help with. So on the next slide, Joanna, please. Uh, Here's how I like to think about the problem. It's literally a black box. Software is, and it's made of all sorts of types of components. The small little cubes in the big cube are the components, and the components themselves can be anything. They can be, software. They can be artifacts. They can be models. They can be data. They can be multimedia. Every single box represents something which the program needs to actually run. However, below that surface, there are all sorts of issues that might be hidden from the end user. And we've highlighted a few that we commonly see in software coming from malicious code being embedded. Think about all of the open source attacks which are ongoing from Shai Hulud, for example, as one of the most recent worms that has hit npm, to these malicious MCP servers that are also in the open source space. So malware could be part of the software package that you want to use within your organization. However, the intent of the software might not be malicious by definition. It could be tampered with, which was certainly the case with companies like SolarWinds getting attacked and their software being compromised by attackers adding backdoors to it. So that's what we call tampering. And software can be shady. Some software might do things that you don't want in your organization, and those behaviors could be suspicious by definition or suspicious in the context of how you want to run software. So that's why we prescribe deep software inspection, and our platform is excelling at that. So on the next slide, Joanna, please. Uh, Now, specifically talking about models themselves, there's many different types of models, but in general, there is a set of training data which is used to create the model. A model can be either like a classical machine learning model or a large language model. And during the process of training, you're literally using GPUs to compute values for these nodes, and then that data representation is the model itself. It needs to be saved to be used through this process called serialization, which basically just saves the model on disk so you can actually use it, which is where the problems start. There are many different types of formats that machine learning scientists use to store the models. One of them is particularly problematic. It's called Pickle. It's a Python serialization format, which by itself can contain the data about the model, but also code, which is used to load the data itself. And that code can be malicious because it can execute any type of a command it likes when the model is being loaded. So during this serialization, which is literally loading the model before you're using it, this arbitrary code can get executed. Now, this isn't a problem exclusive to Pickle. There are other file formats used by data scientists that also can contain code. But important to say is that there are alternatives which are safe, and they're even called safe, safe tensors, for example, being one of them, which kind of eliminate this type of a threat. However, there are other ones, even in the safe model space. There are still scripts which load the model, and the model itself can be tweaked, as Doug was mentioning earlier. Individual parameters of the model could be changed, and latent behaviors could be introduced. So just because there's no code, that doesn't mean the model might not be malicious. In the next page, Anna, we have an example of one such model. So Reversing Labs threat researchers earlier this year in January were researching, are there any malicious models hosted on Hugging Face? Hugging Face is the world's largest repository of models. Recently, I read a statistic that there's more than 2 million models being hosted on Hugging Face nowadays. And most of them are the ones you've heard about, like your DeepSeeks and your Mistrals and your Gemmas and so on and so forth. But there's a lot of buzz in the data science community, and everyone's using these models to generate their own. So they would kind of fork the model, do additional training, and then publish it for others to test. They're all kind of competing on leaderboards who makes the best model in a certain use case. So it's very common to have data scientists actually download a whole bunch of these models just to test. And the malicious models that our researchers found were malicious pickle files, meaning that they did execute hidden code when the models were being executed. Now, there are other malicious models over time that were found within Hugging Face, and there are other issues that were detected since as well with pickle as a file format. So we are recommending that people just try to move away from pickle as this de facto standard that it nowadays is for data science in general. So safer alternatives are better. On the next slide, Joanna, please. We have an example of how that looks like in our platform. So if you were to submit one such file, and this was, I believe, that example, you would see that, yes, this is a malicious file because it contains malicious serialization data. And types of checks that we execute against these files are, well, we look at the code, and alongside the code, alongside the model, you get the code, which is in this case Python code. That Python code is then executed, well, not executed, scanned for anomalies. So we look for, code execution patterns inside various networking capabilities. Basically, we try to understand what that data is within the model. So if the code is present, how it's going to interact with the data in the model itself. We have a whole bunch of policies that trigger based on undesirable behaviors. And in this particular case, those policies are classifying the model as malicious because it's also trying to do code execution. It had some networking capability as well. So when you kind of add it all together, you get something which is almost always undesirable for an organization. On the next slide, please. Uh, we get to how we present this data. So, one of the artifacts of our analysis is the ability to generate a comprehensive bill of materials, which includes the ML BOM or machine learning bill of materials, which tells you everything you need to know about the software package. So, in addition to software bill of materials, your components which are present, we produce a list of machine learning models which are embedded within the application itself. They're also verified to tell you like that they are the original models, if you will, coming to you directly from Hugging Face, and that they are as publisher published them. They haven't been tampered with, and if they have, that's also going to be noted as well. So you'll know that the model is similar to a model that we've seen before, but it would not have a verified check mark. So you would kind of know, oh, this is just merely claiming to be Gemma or anything else. Obviously, machine learning models can be fine-tuned, so you would kind of know as well, is this something a researcher has published or something which is completely unknown and from somebody who doesn't have, well-established reputation in the community. So on the next slide, we kind of show you how we enrich that information as well. So model cards are basically the information about the model itself. And in this case, we are looking at Gemma as well. So this is a verified model published by Google, coming to you from Hugging Face, has a certain license, has certain capabilities. But on the right, we have a partnership with a company called Splix, and Splix excels at analyzing model behavior. So essentially, they have automated red team testing capability that we've integrated into our platform that tells you, well, how are these models behaving? So if you were to use the model by asking it questions or prompting it, how well it would behave in certain categories of issues. So, can it be jailbroken? Can does it align to your business practices? Does it refer to a competitor? All these things are parameters that we test for. So literally, we're trying to attack the model to figure out how it's gonna, resist. And what we've learned in our cooperation with Splix is that a lot of these models out of the box they don't perform well because there are no guardrails when you download the model from Hugging Face. You're literally using it raw and it's going to do things that you might not agree with, and most of them really will score lowly or badly because you need to establish guardrails. What this report essentially tells you is where you need to put the most emphasis on. So when you're doing your hardening, which types of issues that the model is most susceptible at. So they're all various degrees of bad, if you will, when you talk about the local model, stuff that you would run. But if you talk about the cloud models, stuff that's being run for you, think about ChatGPT and Gemini and all the other ones, they already have most of these security guardrails deployed. However, even then, some of them can be bypassed, as we kind of reading in latest threat research as well. So on the next slide, please, uh, which gets us to the SaaSBomb. SaaSBomb is a very good companion to the machine learning bill of materials because it enumerates all the cloud services that the model is talking to. And you need to know that because the model might not be within software. Any application could be just reaching out to ChatGPT API, and that needs to be enumerated for the proper application risk to be inspected. So on the next slide, please, we get to next slide, Jonah. We get to, how do you systematically manage AI risk? Well, since AI can write code, you need to be able to scan everything that both are you're using to build software applications, but also the output of it as well. You need to create bills of materials because if something goes bad, down the road, you need to know what was used to build a certain application. And also, you need to understand every single component from the standpoint of risk. Is it malicious? Does it have latent behaviors? What is it talking to? And things like that. And on the next slide, Joanna, uh, we kind of have a representation of how the SAS bomb looks like as well. It is literally the set of API endpoints that the application is going to talk to. And it's also telling you for what purposes are these APIs being used. So from your simple chat exchange, you're talking to an AI, to exchanging files and getting queries and getting location data. All these things are services, and not necessarily all of the services in the application are just for AI. Some of them are data that the AI needs. So, for example, for an MCP server to tell you the weather in your town, well, it first needs to know where you are, and to do that, it's literally gonna query your IP address, get your location, and then get the weather data for that particular location. So all of these kind of interplay with each other. On the next slide, please. So, software has varying degrees of quality. Our philosophy is to be able to help people get to the highest quality possible and then keep them there. So we created this concept of safe levels, basically telling you how software evolves over time. Next slide, please, Joanna. There we go. So from level one, which is your basic set of criteria of how does what's the basic things that you need to do to make the software secure, to the most comprehensive check as well. These are gradual, and they're guiding developers towards building better applications. And then, yet again, as output of our analysis, you get both the bill of materials, including ML and SASBOM, but also these, reports that guide developers to tell them where they need to put the emphasis and how they need to improve the applications to actually satisfy criteria of the consumer. And I guess that's it from us. Doug and I kind of wanted to share what this new reality is. Doug, if you want to say a few words.
Yeah, I think it's important that uh, as as you go into your organization, go back to your organization after this presentation, you think through some of the issues that AI presents in your software supply chain as well as your AI supply chain, and think about past attacks and uh, like and then envision that application of that taxonomy that we covered earlier is a really important thing to just set down and figure out where you're exposed. And then that's all related to this final point about spotting anomalies with behavioral based detection. I mean, if you haven't thought about this whole new age of subtle AI attacks or devastating AI attacks, then what you have to do is think about the new solutions, which some of which involve behavioral detection, and you have to think about all these new guardrails you have to put into place. I guess now is the time for questions.
Yeah, if anybody on the webinar has any questions, Doug and I are happy to answer them.
And earlier, somebody asked whether or not you will receive slides, and the answer is you will. All the attendees will receive an email subsequently from us, and it will contain a PDF of the slides.
Okay.
Questions?
All right. We are at time. Tomislav and Doug. Oh, we do have a question that just came in. How do you handle AI browsers and how do you detect data exile?
Oh, great question.
Exfil,
Exfiltration.
sorry.
There you go. Yes, thank you. Not our area. We don't have an agent and we don't deal with that particularly. However, it is a very interesting one. I'm particularly concerned about prompt injection in that particular space because I've been using Gemini, for example, to do deep research, and while it's doing deep research, it managed to prompt inject itself. So while I was trying to summarize some documentation that I was reading, I got a very nice little blurb about two rappers being in a battle and who's winning in this particular case. So AI browsers make this a little bit more challenging, and I'm excited to see, what the industry comes up with.
It's just interesting to note that the vendors like OpenAI, as well as I guess Perplexity and Comment, they say that you should use the version which is under subscription, which has more safeguards than the open version. So that's one step that you can take that may reduce the attack service.
All right. Don't see any other questions coming in. We hope you join us again. We have another webinar tomorrow and another great roundup next week talking about more of these supply chain breaches that have happened this past year. So we hope to see you. And again, Tomislav, Doug, thank you so much for your time and everyone for joining us and taking time out of your day. We appreciate it. Happy holidays.
Thank you all.
Thanks. Happy holidays.